We're into page 152 of your student journal, last section of the chapter, 5.7, Systems of Linear Inequalities. If you found systems of equations easy, or not, sorry, not easy, but doable, and you understood how to graph linear inequalities, systems are not going to be very far off. Just like systems of equations, this is just when you have more than one inequality. For systems of equations, the solution is the point of intersection, wherever those two lines meet, right? But because an inequality has a shaded area for a solution, then the solutions for systems of linear inequalities is not a point of intersection, but an overlapping area. So we're going to skip through these. Let's see. And I'm actually going to try and go through this in different colors so that you guys get a sense of like what's happening. So for this example, graph each inequality in the same coordinate plane. Find the intersection of the half planes that are solutions of the inequalities. This intersection is the graph. Another way to think about this is just find the overlap. Find the overlap. So for instance, I'll be trying to do this in, let's see, I'll do it in black and blue. So I'll do it in blue and red, let's say green and blue. And then I'll make the overlap black. So here is one part. Oops, sorry, let me reset. Here's one part. Y is less than x plus 2. So that section is right here. Y is greater than 2x minus 1, which is this part right here. And then the overlap is right here. So when you do this, I shaded all three just to show you what's happening. But when you shade it, the solution is just the overlap. You will not have to shade three different sections. Or if you do, you can make it like lighter gray shading. And then when it comes to the overlap, you'll just do it darker. Tell whether the ordered pair is a solution of the system. So again, these are very similar to systems of equations. And as a reminder, does a solution have to work for one or both equations, or in this case, inequalities? And the answer is both. So we got to check both. 0 is greater than 2. Well, it already doesn't work. So we don't even have to check the other one. It has to work for both. So if it doesn't work for one, it doesn't work for, it doesn't matter. So this is no, not a solution. Negative 1, 1. So this is my y. So I plugged in that 0 because this is y, by the way. Y. 1 is less than 3, okay. And then this is my x. So 1 is greater than negative 1 minus 4. 1 is greater than negative 5. Yes. So this is x, this is y, and this is a solution. Check mark. That's it. Just substitute x and y, and you say whether or not the inequalities are true or not. If it's true for both, then it's a solution. If it's false for either of them, then it's not a solution. Graph the system of linear inequalities. So again, we have let's see, a dashed line. So negative 2. Oh, why won't it show? Okay, a dashed line at negative 2. So boom, 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 boom. That's a dashed line, not connected, or not solid. Y is less than 3x. It actually ends up being, let's see, 3x. So 1 times 3, down that away. Okay. So if I connect the dots on this, it looks like that. Okay. Y is less than or equal to 3x. So let's actually just connect that here. Let's undo that. Something like that. So like I said, I'm going to shade in a few different colors, blue and green. Y is less than 3x. So 2, yeah, this area is the one that is for this line. So I'm going to graph or I'm going to shade this. And then I will go to green for the other one. Y is greater than -2, so we're going to shade this way. And it should be kind of clear where the overlap is. So again, you don't have to use 3 different colors for this or anything, but it certainly helps if you do a light shading here, a light shading there, and then when it comes to the overlap, you just color that in really dark. Y is less than 3, X is less than 2. Both of these are going to be dashed lines. Y is less than 3, 1, 2, 3. X is less than 2. Now for shading, let's see here. The heck? Okay. Y is less than 3. And then X is less than 2. Oops. So the overlap is the bottom left quadrant of this graph. Alright guys, let's see here. Same thing, except, you know, before you graph, make Y, get Y by itself. So this is Y is greater than or equal to -2x plus 1. Subtract 2x and divide by 3. Subtract 2x and divide by 3. So I'll have -2/3 x plus 2. That is this one, just transformed, just isolated with Y. And this is that. So again, make sure you graph each line correctly, graph each inequality correctly, and then shade the overlap. Write a system of linear inequalities represented by the graph. This one might be a little bit harder for you because, well, let's see. We have a solid line here and a solid line there. Or sorry, not solid, dash. And this looks dashed as well. So x is 1, 2, x is less than 2, and 1, 2, 3. Y is less than 3. That's it. That's number 9. Let's see here. Y is greater than 1. Y is less than 3. I'm just doing this without much explanation because like it literally is just you coming down and recognizing these lines, right? Like it's not an x, because if it was an x, it would be going like that. Let's see, moving forward or moving down. Wow, last 2 problems of the chapter. So if we use a y-intercept and use a slope, the y-intercept is 1, and the the y-intercept is 1, and the slope is 1. This is a solid line, so you know it's going to have an equal. If you're shading above, it's a greater than sign, and then this one is y is less than, because this is a dash line. Negative slope, -1, -1, down 1 over 1, down 1 over 1, down 1 over 1. But the y-intercept is the same. And lastly, let's see, y something x -2. Why do I say that? Because you start right there, -2. Y-intercept, down 1 over 1, down 1 over 1. And we're shading above it, so we could say it's a dashed line, so we could say y is greater than -x minus 2. This one starts off right here. My y-intercept is +1, and the slope is still -1, though. -x plus 1. And what's the overlap here? Oh. Okay, this one must be less than then, because this is the overlap. This area is the overlap. This is part of shading. This is part of shading. Okay. All right, guys. That's it for the whole chapter. That's grading. That's graphing systems of inequalities. If you have any questions, make sure you ask your teacher or let me know.